This video is for the Akron Cooperative Medical Laboratory Science Program, and this is an introduction to Panacell 20, which is the reagent red cell panel used for identifying blood bank antibodies in tube. You can see that included in here we have an antigram, which I'll explain in a minute. We've got a package insert, and we've got 20 different cells. This box of reagents represents 20 different donors. So just think about that the next time that you are doing some testing, the amount of sacrifice, I guess, that folks need to do to be able to provide us with what we need to do our testing. And this is part of the reason why blood banks are so precious and so expensive, because each one of these represents a person. So this cell number 1 is from one person. And cell number 1 corresponds on this list to number 1 on the list. So we've got cell 1, number 1. That's the official donor number that they were given by Immucor when they donated. That is their phenotype, written out in a form that you will learn once we get to that. And then each of these antigens across the top, so DC, little c, big E, little e, CW, Kel, Chelano, KPA, JSA, all the way over to the XGA, the sex-linked. This bottle, these red cells from this donor, were tested against Anacera for all these things so that they know what's positive and what's negative. And as you go across, you can see donor 1 is positive for D, positive for big C, negative for little c, negative for big E, positive for little e, positive for CW, and so forth down the line. So donor number 1, cell 1 in this panel, you go across, and that's what their phenotype is. Similarly, look at number 2, corresponds to number 2 on the sheet. That's unique donor number. And if you go across, you can see what they are positive and negative for. And it's very helpful that we've got different donors with different phenotypes. Otherwise, we'd never be able to figure anything out. So you notice that the top part, everyone is D positive. The bottom part, so this is cells, I can read that one, cells 11, 12, 13, all the way through 20. So cells 11 through 20 are all D negative except for the last one. And that's very helpful if you're suspecting an anti-D in your patient. Then you can automatically come down to these cells and run these instead of wasting patient plasma running these. But again, let's take cell number 18, for example. You come down to number 18. It's a little r, that's its donor number. They're negative for D, negative for big C, positive for little c, negative for big E, positive for little e, negative for CW, negative for Kel, positive for little k, and so forth down the line. So I hope that helps explain what these are. These cells are used exactly the same way as your antibody screen cells in tube. So these are equivalent to these. So everything here is type O, and you remember that we need type O so that we don't get interference by the anti-A and anti-B antibodies that might be in the patient plasma. Because all of these cells lack the A antigen and all of these cells lack the B antigen. Therefore, if those antibodies are present in this patient specimen, they will not react. So we can be fairly sure that what's reacting is because of these antigens on the list. So testing is performed exactly the same way. In tubes, you have 2 drops of patient plasma. You've got 1 drop of red cells in 1 tube, and in this case you're going to have 20 tubes, so you would put 2 drops of patient plasma into each of the 20 tubes, and then tube 1 you'd put cell 1, tube 2 you'd put cell 2, tube 3 you'd put cell 3, etc., all the way down. And of course make sure your tubes are properly labeled, patient ID, medical record number, and the cell number. You also, once you get to the point where you are doing rule-out cells, you want to make sure that you include the lot number of the cell, because you'll be pulling cells from different panels. The lot number is here, if it'll focus. There we go. Oh, maybe. There. So lot number, expiration date. Make sure you record those, the lot number, and then -3 in this case because you use cell number 3. And that'll get written on this sheet. So a little more explanation about this sheet. This is where you're going to write down your patient information. So you want to put your patient name, medical record number, children's hospital, their blood type, and once you're finished figuring out what the antibody is, you write the antibody result at the top, your initials, and the date that you did the testing. So in the result columns, it has everything empty right now. You are supposed to write in. If you use this panel for tube, your first column will be immediate spin, second column will be 37, third column will be AHG, fourth column will be check cells. And as you spin this down, you read it and grade it, you document your result. And then you document your results for all 20 for immediate spin first. Then you go to the next step where you incubate them at 37 with LIS, spin that down, read that, that goes into the next column, which would be labeled 37 degrees. Then you take that, take those tubes, put them through the cell washing process, and then add your AHG reagent, spin them down. The next column, you would document all of your reactions as you shook them off. And then if any of them were negative, then you would add check cells, and you add your check cells only to the negative reacting ones because you want to verify that your AHG reagent worked. Remember, the check cells are coated with IgG, and the IgG on those check cells will interact with the IgG in the AHG reagent if it's working properly, which would give you approximately a 2+ reaction. And if that reaction occurs, then you would mark that in the fourth column for check cells. Refer to your laboratory information if you have any other questions regarding antibody identifications.